Hi, welcome to this talk about understanding information need using functional magnetic resonance imaging offered by the Stanford Scholar Initiative. Imagine you're researching on the internet using a search engine, but somehow you don't exactly know what you're looking for. This underlying thirst and hunger for relevant information is known as information need. Currently, information retrieval is like a game of chance. Information retrieval systems use the best match principle, and they need you to go through many documents and redo the search to satisfy your information need. Sometimes these systems even fail, and your information need is still left unsatisfied. Information need is not quite the same as the human need for air and water. Behavioral studies suggest information need is a way to satisfy more fundamental needs. For example, searching for music satisfies your recreational need. What if we can design information retrieval systems that can more directly understand our information need? Well, we first need to understand what information need is. Some studies looked at different physiological signs studying for information need, but they haven't been quite useful until someone decided to look at the brain. We can't simply open the brain and find information need. The brain operates by the activation of brain cells, which is essentially electric signals. Every thought and action is triggered by these electric signals, and these cost energy, which is observable through oxygenation in blood using a machine called the functional magnetic resonance imaging, or more commonly called fMRI. However, because humans are always thinking, breathing, and moving, brain activities happen all the time, all over the place. The short flickers of information need brain activation patterns would be difficult and would require a well designed experiment. The paper we are presenting explores manifestations of information need in human brain using fMRI. It was intended to close the gap between information need and information retrieval and lay the foundation for potential devices that can automatically feed back information need to information retrieval systems. Here are a few important research questions that this paper will try to answer. The study placed 24 participants within an fMRI scanner. They were put through two scenarios. First was question response and the second was question response search. When participants see a question that they don't know the answer to, they can choose the option need to search, and that's when the scans of their brains are expected to show the hints of information need. To minimize unnecessary brain activations, the authors took care to separate the viewings of questions, options, and the respondings, giving each phase at least 4 seconds. A full anatomical scan was performed. After pre-processing to eliminate noise and certain factors, the information need scans were overlaid onto the anatomical scan to map out functional activations of brain maps, accounting for spatial variations across participants. The study found that 5 clusters in the brain regions lit up when participants needed to search, while only 4 of the same clusters lit up when they knew the answer. In other words, information need manifests here. The posterior cingulate, known to be a critical hub involved in coordinating brain activity between internal and external environments. Firstly, this discovery implies that information need would involve switching brain activity between internal processing and external processing. Secondly, the fMRI brain data showed clear manifestations of information need, since brain activities differed according to whether participants experienced information need or not. Third, the brain activity of information need actually preceded the actual decision to search, which is definitely an early stage. Lastly, between whether participants conducted a search query or just simply decided a search was necessary, differences appeared in the brain activation of information need. The real-world applications of this result could be huge. Hooking up our brains to computers via EEGs, we can detect information need when it arises, and computers can instantly recalibrate search results, which means effortless and more accurately defined search. Having established the posterior cingulate as the likely region to observe information need, further studies can leverage this to study information need under varied scenarios, hence providing us the neurological details to create new possibilities. With this, we come to the end of this talk. To view more talks, please visit scholar.stanford.edu. Thank you.